Before we begin today's lesson, it will be helpful if we review similar triangles. What we know about similar triangles is, or any triangle, is that if you have two angles that are the same, in this case both of these are 90 degrees, and these are 40 degrees, that must mean the third angle is the same as well, because they both add to 180. So if this angle is 50 degrees, then this angle must be 50 degrees as well. And if there are similar triangles, we know from past lessons that their sides are in proportion. So 8 is to 14 as 4 is to A. Here we had to divide. There's a few ways to do this, but we could divide by 2 to get 4, so we could divide by 2 to get 7, or we could think of just simplifying it, or we could do some cross multiplication. But however you figure it out, A is 7. This is the first time you've seen parallel lines in a transversal this year. You did this last year in 7th grade, but this year, just as a little bit of a review, which angles are congruent? Congruent means they have the exact same angle measure. So for example, 1 and 4 are congruent because they are vertical. 5 and 8 are congruent because they're vertical. And then 1 and 5 and 4 and 8 are corresponding angles. Corresponding angles are also congruent. So 1, 4, 5, and 8 have the same angle measure. For that same reason, 2 and 3 vertical angles are congruent. 6 and 7 are congruent because they're vertical. 2 and 6, 3 and 7 are both corresponding. So that means they're congruent as well. So if the blue lines are parallel, 2 and 6, so this one right here and this one right here are corresponding. They're in the same position, different line, so they are congruent. They are the same angle measure. So the main focus of our lesson today is determining the slope using similar triangles. So we're trying to find the correlation between similar triangles and slope. Before we go any further, I'd like you to take a moment to watch this Learn Zillion video for some great background information. If the link does not work for some reason, it's the Learn Zillion code 1414. So go to learnzillion.com 1414. You may need to pause before you can continue if it does not play in this window. Alright, after watching that video and our warm-ups, this should be pretty easy. First, we're just going to be looking at the measures of different angles. Remember, the one in the middle, the letter in the middle, is the angle we're looking at. So first we're going to be looking at AEC. So this angle right here. This angle right here is a 90-degree angle. It is a right angle, so it's 90 degrees. Then let's look at BDC. BDC, so this angle right here also forms a 90-degree angle. It is a right angle. All right, then what angle do the two triangles have in common? Well, if you look, they overlap and they have angle C in common. What this tells us is that since they both have a 90-degree angle here, a 90-degree angle here, and they have this one in common, that means B and A also must be the same angle measure. And so what it tells us is that these triangles are similar. So let's start relating what we know about similar triangles and rise over run, or the slope. So the rise, we're going to be talking about ACE right here, ACE. So ACE, the rise, starts at 10 and it goes all the way up to 40. So 10 to 40 is a rise of 30. The run, it goes from 2 to 8. So the difference between 2 and 8, if we counted it or we could subtract, is 6. So the slope, remember, is just that rate of change. It's the ratio between the rise to the run, but simplified. So the rise was 30, the run was 6, so that simplifies to 5. 30 divided by 6 is 5, but then we need our, because it's application, we need our labels. Meters per second. Remember, the rise is the change in y, where the run is the change in x. All right, let's look at the next one. Triangle BCD. Here's BCD. The rise is the vertical change. The run is the horizontal change. So vertically, it goes from 10 up to 25. 10 to 25. I know it's 25 because it's halfway between 20 and 30. Between 10 and 25 is 15. The run, it goes between 2 and, I'm going to come down, all the way down, is between 4 and 6. So right here is 5. So between 2 and 5 is 3. So the run is 3. Remember, the slope is the y change over the x change, rise over run. So that would be 15 over 3, but we can reduce that, and we always want the reduced form. So 15 over 3 is 5 meters per second. And we know that for proportional relationships, or relationships that are changing at a constant rate, so the rate of change is constant like this one, we know that it is going to be the same. So to predict Casey's speed from 8 to 10 seconds, no biggie, we're just going to use the same rate of change, 5 meters per second. It won't change, it's going to be the same. All right, now we get to do the fun stuff. Now we get to actually draw lines given what we know about slope. So draw a line that starts at 0, 0. You know that's the origin, so down there in the corner, 0, 0. Sometimes you have 4 quadrants, but remember it's where the axes cross, 0, 0. And has a slope of 1 to 4. Remember, the slope is the ratio of rise to run. So if we had similar triangles, it would be the vertical change. So the vertical, this was the rise over the run. So it's 2 numbers, but together it forms the ratio of that one right there, the hypotenuse. So think of what we learned in the Pythagorean theorem, rise to run, these 2 legs, the ratio of them. So what this is telling us is that the rise is 1, so to get to the next point we have to go up 1. So just 1, so like that. And the run is 4. Now these are not numbered, so that's telling me that each little mark is just 1. Sometimes they're numbered differently. So we went up 1 and over 4. And that's going to be my next point. And then I'm going to do it again. And I'm just going to keep going, drawing these triangles. And I ran out of space, so I'm just going to go 1 past it and connect. And there is my line that goes through 0, 0 that has a slope of 1/4 because I went up 1 and over 4 and up 1 and over 4. So it's a series of similar triangles, 1 to 4.